Hello everyone, my name is Kike Lomo Oluwemimo Osilo. I'm your physics instructor for the eScience laboratory today, and you'll be expecting the following learnings to take place. The first one, we are going to have electricity, which I'll be handling, and we're also going to come up with mechanics. And what are our expectations? We believe that at the end of the session, we expect students to be able to look at the diagram given and be able to make the connections either for electricity, then for mechanics, be able to interpret the diagram and be able to put it into practice and be able to get their slope, draw their graph properly. From the experiment, they should be able to explain the precautions that they take during the course of the practical session. I wish you well in your examination. I wish you success as well, and come along with us and enjoy the practical sessions for physics class.
eScience Practicals, achieving success in science subjects.
Good day. My name is Shogodine Olalekan Aziz. You are welcome to physics practical class. Our practical class today will be based on mechanics, and what we are treating in mechanics is equilibrium. With me, I have the following apparatus here. I have a knife edge here. You can see the knife edge. I have a meter rule here, which is 100 centimeter. I have masses here. You can see the masses here. I have them. Then a tape, a thread. Now, what do we have today? We are going to set up the apparatus based on the diagram displayed. Now, the diagram displayed in the screen has an unknown mass, P, to your left, with 15 centimeter from the center of the ruler. Another unknown mass, Q, to the right, 10 centimeter from the center. And a variable mass, M, which will be adjusting to ensure that you have equilibrium when you set up the apparatus. But before you do that, the first thing you are going to do is to discover the center of gravity of the ruler, where the weight acts. The first thing I'm going to do that now. You can see the ruler. I want to determine the center of gravity. So place it like this. Ensure that the room is air-free. Ensure that there's no drought. Good. 50 centimeter mark. You will see it rotating a bit at the center of the 50 centimeter mark for that particular ruler. So we are going to record that one down. First, you will record G equals to 50.0 centimeter mark, because on this ruler we can have our value up to 1 decimal places. You can have 2 decimal places. The next thing I'm going to do is to set up the apparatus based on the instruction given. From the instruction, we have unknown mass P. The P will be given to you by your teachers in the lab, and it will be taped unknown mass. You will also be given Q, and you have a varying mass. So you take your thread. Once you take your thread, you fold it, let it be thicker. Then you take the particular mass you are given, P, you roll it, then hold it together like this. Then you tie it together. So once you tie that together, you tie the next one and fix it together. So I have a set which I've planned there. We now move it. So the first thing I'm going to do is to lift this up and place it on the knife edge. Since I know the center is 50 centimeter mark, I will place it like this. But when I adjust this to 15 centimeter mark, based on the diagram says 15 centimeter for P. This is P here. You can see P. I have to adjust to 15. And from the center here, if you see the center here is 50, you adjust to 35. Now that 35, you can decide to take a tape and tape it down there so that it will not be moving up and down. So I'm going to do that now. I'll ensure I put it down, take the tape, open the tape up. I'm taking this. That's for the first mass. For the first mass P. For the second mass Q, which is unknown, provided by my teacher. Then I set this up as expected. Now I have it here. Now at 35 From the center here is 50. If you count 10 backward, it will be 40. 5 backward, it will be 35. So this will be exactly on 35. So I'm taking the tape from here. Tape it up at 35. Is there? The second mass supposed to be at 10 centimeter mark. 10 centimeter from here should be 60. From the center is 50. Okay, I'm taping the second one at 60. Good. Now, the next thing I need to do is to attach the varying mass. The varying mass, which I've looped up, I have a varying mass here, which I've looped up. Let me put this down first. Since I've attached this, it will remain at that position. And I'll prepare the thread for the varying mass. Okay, so here I have this. Let me fix this. Now, based on the instruction given, the first varying mass we have to test is M equals to 40 gram. M equals to 40 gram. The next one is supposed to be 50, 60, 70, and 80. Now you can see I wrote M here as the mass and I put the units immediately. So 40.0, 50.0, 60.0, 80.0, because there's no calculation done here. Anytime we do calculation, we must take our reading to 3 or 4 decimal places. So I'm raising this up now to put it back. Because I've taped it, it's not moving away from that point. I've taped this one too, it's at that point. You can see this is moving to my right here. So you have to adjust these masses until you have a balance point. So I'll be adjusting it. Let's see what will happen to the ruler. As we're adjusting, it will try to come up. Adjust. Now the first mass I'm using is, don't forget, is 40 gram. I have 2 of them here. 2020. Okay. Okay, it's coming up. Ensure it's at 50 centimeter mark. Now it's going this way now. So I have to adjust it back a bit. Back. Back. Still gyrating at that point. Good. Almost there. Still see a little bit of shaking here. Based on what I have here, from the center here to the unknown mass P, I have 15 centimeter fixed from the instruction. From center here to this Q, I have 10 centimeter fixed from the instruction. My varying mass now, from the center to this place, now here I have 50, this place I have 32.5. Now, 32.5, I have to do a little bit, 82.5 rather, sorry, I have to do a little bit of calculation, 82.5, and the center is 50, then I have to take away that. Here I have 5, here I have 2, and I have 32.5. Meaning my first reading, the varying length Y is 32.5. So here I have Y in centimeter 32.5. 32.5, that's the first reading. Now, from the way I prepare my rope and the way I attach my mass, I've done it in such a way that I can easily add another mass to it. I don't have to tie another rope again. We are going to second reading now. After the first reading, we maintain our center 50 centimeter. And don't forget our first reading was 40 gram. Now we are going to 50 gram. So we look for 10 and add 10 to the 40 we have here. Like I said, you have to do the rope in such a way you can add the masses continuously. So this 10 gram is added to this, we now have 50. Now maintain the center, we adjust, look at it, okay, we observe it, we go again, ensure that there's no drought. Perfect. Okay, so we have exactly 76 here. exactly 76 here. Now from the center we have 50 and this place we have 76. So 76.0, 50.0, you subtract that, you have 26.0. So here will become 26.0. Then the next thing we do is to proceed to other readings. We proceed to other readings and you do 60, 70 and 80 gram, then we obtain the values. Just like the way we have done this and we have exactly 76. The value for the 60, 70 and the 80 gram is shown on the screen now. Please look at that and follow. Now let's quickly proceed to the inverse of the mass as instructed in the question. M inverse is same thing as 1 over m. So I'm going to take the inverse of 40 gram. So here I'll put m inverse. You know the unit here is gram. This will be gram inverse as well. So 40, I have 1 over 40. That will be the first value. The second value will be 1 over 50. 1 over 50. So what will 1 over 40 give us? What will 1 over 50 give us? The first value will give us is 0.0250. While the second one will give us is 0.0200. So you complete this as shown on the screen. Now the next thing we are going to do is to plot the graph. But before we go to the graph, we have to look at the arrangement of the number. If you see is 0.0250, this might be a bit difficult for us to take to the graph. So the first thing we are going to do is to put it in standard form. So how do we put it in standard form? You look at it. This is before the first digit, 0.0250. I can decide to take this to 2 decimal places, 3 decimal places. But I would prefer to take it to 3 decimal places so that I can have an easy reading on the graph. So this, I have to extend this again and put M inverse, G inverse, close, times 10 raised to power minus 3 because I'm shifting the points backward. 1, 2, 3. This one will be 25.0. This will be 25.0. This will be 1, 2, 3. 20.0. Like that for other reading as shown on the screen. So after this now, the next thing we are going to do is to plot the graph. I'm going to rub off this and let's move to the graph. Now, taking my axis, that M inverse is to be plotted on the ordinate. Ordinate there means the vertical axis, while the Y is supposed to be plotted on the abscissor. The abscissor is referring to X axis. So let me start with this. Okay, this is what I have. This is what I have on the graph. Now I am starting the graph from 0, 0, the X from 0, Y from 0. That is the origin. But the first thing I need to indicate is to indicate that the vertical axis is M inverse in brackets G inverse times 10 raised to power minus 3, while this is Y, which is in centimeter. So we start taking the reading. Now from the reading, from what I have in the Y axis, then I'm going to take my reading from 0 to 5, 0 to 5.0. The next one will be 10.0. The next one will be 15.0. The next one is 20.0. The next one is going to be 25.0. The next one is 30.0. Let me take it down to 35.0. And this is Y in brackets centimeter. That must be there. For the vertical axis, I'm going to take it from 0 to 4 in order to expand the graph very well. The next one is going to be 8. Okay, this is 4. This is 8. this is 12, this is 16, this is 20, I have 24, I have 28, I have 32. So I'm going to end it at 32 for that. Don't forget that we have 10 raised to power minus 3. Now I will start the plotting of the point. Based on the table provided, I'm going to look at the points now. Look at the first point is 25.0 against 25.0 against 32.5. Against 32.5. 25.0. You come here to the vertical axis. You look for 25.0. Don't forget, a bus from here to here represents what? And that takes us back to the unit of the graph. How do we take the units of the graph? Look at the way we have represented the value. You see the scale as shown in the screen. You can see for the y-axis, which is the vertical, you are going to have 2 centimeters to represent 4.0 times 10 raised to power minus 3 per gram. For the x-axis, and 2 centimeters to represent 5.0 centimeters. The scale taking, meaning on the x-axis, a bus is going to be one small unit bus is going to be 5/10, that is 0.5. Now, but on the vertical axis, where I have 4, you can see there are 10 tiny buses there. I have 4/10, that will be 0.4. So when I'm taking my readings, I must put all these into consideration because it will not be easy to just look at 25 on the graph and just draw 25 because I've spread out my scale from 0.4 from 0 to 4, 8, 12 on the vertical axis, 0, 5, 10, 15, like that on the horizontal axis. So the first point to plot is I'm plotting 25.0 times 10 raised to power minus 3 against 32.5. Okay, I have here 30. I can see 30 here as shown on the screen. You can see the screen now. You move the point. You count the number here. And I'm going to 32.5. 32.5. So 2 buses, 1, 2. That's 31. Another 1, 2. That's 32. Then a smaller one at the center. We go up like that. Against what? Against 25. Now here I have 24. The next bus is 24.4. After that, 24.8. After that, there should be a smaller bus, 0.2 to balance up so that we have 25. So if you trace that, you will have the points there. You can see the points on the screen. You have the points P there. We've taken points P1. Repeat the same thing for points P2, where we have to plot 20 against the y26. We go for the second one, the third one, the fourth one, and the fifth one. So here I label these points P1. As shown in the graph, point P2, you see point P3, P4, and P5. So the next thing is to take the line of best fit. The line of best fit. Now we expect to ensure that you have 3 points on a straight line and the other 2 points, if they are not on line, should be distributed evenly. What do we mean by evenly? Mean we want one to be above the line and the other one supposed to be below it. Not the 2 points at the same side of the graph. So now if you take that, if you put the ruler, then you draw out the points as shown in the graph. Okay, you can see roughly all the 5 points. Roughly all the 5 points enters. Okay, good. That shows you've done We've done a very good experiment. We have taken the necessary step and we are getting a very good result. Okay, good. After doing this, the next thing to do is to find the gradient, which is also referred to as the slope. How do we go about the slope? Ensure that your slope is not a very small one because your mark will be deducted for that. Ensure your slope covers close to two-thirds of the graph. So if I'm going to take that, let me take this, okay, the vertical line down, ensure it's big enough, then you take the horizontal line. Ensure that it's straight, follow the line as shown in the graph. You have to follow the length of the graph, it must be a straight line. So I have 2 points. Just look at the right angle triangle. There are 2 points on the right angle triangle where it started from and where it ends. So for these 2 points, trace it down. What value do you have there? And trace it vertically. What do you have there? Write out the point. The first point, you can call that A, put bracket. You have the value of the first one on the x-axis, the value of the y-axis. The same thing, you go to B, the point 2, you trace it down to x, you have your value, then you trace it down to y, you have your value as well. You put brackets in that. You remember from mathematics, the first one is x1, y the second part of the s1 is y1, y this is x2, y2. Now, if you go back to gradient formula, which is also the slope, we can say it is y2 minus y1 over x2 minus x1. But in this, we are applying the concepts of mathematics, but we are putting the units. Don't forget that the unit must be there. Now, the first thing is to say gradient, the slope, x equals to, in this case, delta m inverse over delta y. So what do we mean? So it means the m inverse 2 minus m inverse 1. Quickly, don't forget, quickly add your unit as well. Per gram over centimeter. Per gram over centimeter, you can calculate that out. 1 over gram divided by centimeter. 1 over gram times 1 over centimeter. So we have 1 over gram centimeter. So we can conclude that the unit here is gram centimeter in bracket raised to power minus 1. That's what these units will give us. Now we go to calculation of the slope. From the graph displayed, you can see that here we have 16 for the lower point and 12 times 10 raised to power minus 3 for the lower point. If you trace it down from the graph there, you will see 16 down. Then to the vertical part, you see 12 times 10 raised to power minus 3. Now for the topmost point there, where we are the first point, we have 30 and 23.2 times 10 raised to power minus 3. Beautiful. Good. Now we can move on from there. Now we say slope equals to 23. Slope equals to 23.2 minus 12 in bracket times 10 raised to power minus 3 all over 30 minus 16. So what do we have? Take your calculator, calculate that out. We are going to have 11.2 for this, and here will be 14. 11.2 times 10 raised to power minus 3 over 14. Now, don't forget the unit. We've derived the unit there. It is 1 over gram per centimeter. So here, If you work this out, you are going to see 0.008 grams centimeter in brackets raised to power minus 1. So this is the slope of the graph. This is the slope of the graph. And note, in the course of taking this experiment, I was measuring some things in the course of taking the experiment that affected the reading initially. I said, number one, you should ensure that you close the windows and off the fan. If not, the draught, the wind will disturb it. So first precaution, you say, I ensured. You're going to use past tense and you did it by yourself. I ensured that I avoided draught in the course of experiment by closing the window and switching off the fan. Number two, I ensure that when I'm taking the reading from the meter rule, I take the reading standing vertically to the unit that I want to take so that I will not be taking a wrong reading. Ensure standing vertically to avoid parallax error of taking a wrong reading. Because if you don't stand vertically, you might be seeing 76 and be calling it 76.1 based on the way you are standing. If you stand at an angle to it to take the reading, or you are going to the other angle, you might be seeing either 76.1 or you'll be seeing 79.9. So there will be a shortage in that. Please take note of that. So after taking our slope, we proceed to other calculation and the materials. Thank you very much.